Alright, welcome to another, well, whatever, draft science video presentation. On the subject of, in the series of videos, basically asking the question, why can't the truth be this other story instead of the story they all think it is? So this is the time dilation subject. The idea that time is some kind of bendable dimension and not just a function that things have by moving. They're just stuck with the idea that they can only move at a rate. Nothing happens instantaneously. I should put this in the keywords. There is no instantaneous, therefore everything has to happen at a certain rate. And the rate is decided by the rate built into the elements, the little bits that are the universe. So I would argue that light is just a force, and that all the forces move the same speed: gravity, magnetism, the little bits that are controlling inside the atom, and light. And so it's the speed of force, and that speed is built into the force. So the force doesn't need to acquire its speed, it already has it. It's just doing it, constantly moving, perpetually, forever. The photon, for example. And as I've pointed out, I would argue that the photon can be seen as a particle moving in a ray at a spacing, and it's just these bits of force, quanta, constantly moving, that push things, and they, in one form without a frequency, they create the push of gravity. In another form, segregated for the two types of force, electron and proton, they create charge and make electrons and protons move and create what we call magnetism. And the movement of the electrons is what we call electricity. Anyway, there's no separate magnetism and electric fields. The two fields are the same things. It's a charge field, and there's a difference between a field that has mixed content, both charges, a dipole, and a monopole field created around electrons and protons. Alright, I don't know if we need all that, but to argue this subject, but it all kind of relates. So since I'm already off subject, I might as well do a little bit on the previous subject of redshift. And I made some glaring mistakes in terms of not setting up some better axioms, making sure I was saying things okay, that we already established as truths. And what I was forgetting is that when photons interact with atoms, and more specifically electrons, they do so absorbing a collection of force, pushing in attention. So it's kind of like, I've used the analogy of a trampoline, and you want to push. The further you push it in, the more energy you get as a rebound. And what you're trying to avoid is the trampoline bouncing back before you hit it again to put more energy in. So it's cocking a gun, like a spring rifle or something. You want to pull the spring all the way back. You want to pump as much air into an air rifle to get the most velocity out. And if you allow the air to leak out before you pump in more air, you get the idea that the bullet will just fall out of the gun instead of shooting out of the gun at a big velocity. And so the interaction between photons and electrons is completely dependent on frequency, on this resonant idea, hitting an electron before a counter force acts on it and pushes it back to its neutral position. And you can sort of see that in black body radiation as a kind of blue shift, in the sense that you're putting heat in a form you can't see, infrared, sometimes, generally, could be argued, at a lower heat, and you're pushing more and more heat in, and you're getting out a higher frequency light. So you're forcing the atoms to create interactions between each other. So they're not just jiggling, they're jiggling and hitting which is causing higher frequencies. So if you have a bounce rate and then you create obstacles that'll increase the bounce rate, you can sort of understand that things will bounce or have interactions more often, create higher frequencies. And so that's sort of the visible light radiation you get from hot objects. Anyway, sort of a side subject, but it's important to that first subject to recognize that the atom that transmits a transparent object, for example, is transmitting the entire ray of light through. The force doesn't work unless it has the frequency at such a high enough level to be transmitted. It won't transmit a low frequency. So clearly the only way it transmits it as a frequency, so as a bulk object. It interprets whole words and whole sentences. It doesn't interpret letters. Using another analogy, I mean, it's amazing what brains do. I mean, this whole subconscious thing. My subconscious is doing some really good physics that I don't get to see. And it just formed this analogy of letters and words and paragraphs. And it's a beautiful analogy for resonance, you could almost argue. The fact that things have to hit at a certain, with certain syllables and certain arrangement of words, of certain poetry. I mean, that's an elegant analogy, and it's the first time I've heard it. So that whole the robot's always working kind of thing, and would it come up with that while I was sleeping? It was just going to wait until this video to show it to me. Really is interesting being alive. Stuff like that is just interesting. Just how much is really going on back there, back there. Anyway, all right, so time dilation. So their theory is, they say a lot of things, that we don't have a real velocity. That is, there's no, if we were to find, or if we were able to place something in the universe that had no motion relative to space, that somehow we couldn't just compare everything to that thing and say, this is what your real net velocity is. Because we sort of do know that things don't travel more than one direction, technically. That their net energy is in one direction, and that can be changed, but at any one moment, everything they exist, everything that's them, is pointed in one direction, in the sense that if you were just to keep their internal structure exactly the same, they would just keep going that direction. So you need an external influence to change them for that direction to change, and it's one vector. So if they're going a little bit this way and a little bit that way, they're going to go this way, actually. They're not going to travel both directions unless a force acts on them to force them to travel both directions. And so this force stuff, it's all rays. It's all straight line force. But anyway, so they say we have none of that. There's nothing inside of something that says what their velocity is. I would argue that it's perfectly logical to understand that the nature of acceleration is the very process of you being changed. That is, the force being pushed into you, you acquiring a bias in a direction, which is a physical property that's inside of you. So if I throw a wrench in space and it keeps moving, that wrench that's moving is actually different than a wrench not moving relative to it. They have a different amount of, the force in them has a different direction, and they have a net byproduct of all that direction. So if I was to use boat rowers as an example, they have rowers that are on net rowing in a different direction, and there's more of them or less of them rowing in a certain direction. So you could see, if you could do a microscopic view inside of something, you could see its velocity. Its velocity is actually something it has, it possesses. It's not just magic. It's a physical thing that changes the physical nature of the stuff inside of you. And I think that's the important thing to understand, that if you're changing something, there's no surprise that you might break it, that its other functions might change. So as I change the disposition of the rowers and what direction all the little boats are going, that I might change, okay, some other process that it has to do, because now I've made that process longer, because there's not enough boats going this way and there's too many boats going that way, and it can't do the thing it was doing before as efficiently. So the simple argument is, time is just a function. It's just something that you have in the universe when everything doesn't happen instantaneously. So if there's less than instantaneous motion, that is, something goes from one position to another position and it doesn't do it instantaneously, well, then you automatically have something called time. And we base time basically on what's the most elemental time, the most elemental movement. And I would argue the most elemental movement is this force stuff. Photons, magnetism, gravity, that's the elemental force, and that's the stuff that sets the standard for what time is. So the rest of it's just basically a simple argument about multitasking. That anything that tells a different time, any clock, all clocks have a metabolism. They have a mechanical function. The pendulum has a length of its swing. If I put an impediment in to shorten the length of its, well, that won't work. That actually will still be a pendulum. No, it won't. It'll go faster. So I'll change the function. I'm just saying, you can use all these examples about different ways of measuring time, which are basically trying to find a standard that depends on some metabolism, some function that's really based on forces. It's always going to be based on the elemental thing. You're really reading, when you're reading the clock, you're reading the speed of light again, because all the functions are based on the speed of light, and just finding a mechanism that is still consistent with that. So some big thing that's bouncing because the wind's blowing, let's say, and so you're really measuring the wind speed, but you're counting just how many times the balloon goes around. So there can be different interpretations of the same thing, and so you're just trying to find gears that are all consistent, that basically do measure time accurately, that are reliable processes. So all clocks have these gears, and all those gears can be messed up by giving the clock a velocity, or taking it out of gravity, or putting it underwater, or doing whatever you do. You'll break the clock. So this idea of time dilation is just really, we're measuring how different clocks break. Now, they can't do time dilation experiments with a stopwatch. It just isn't going to work, because it can't measure time on the tiny scales of the difference for minor velocities, and we can't move clocks at very fast velocities, so it's really hard to do the experiment on mechanical clocks that do have a lot of gears. So we try to reduce the number of gears. Well, a reduction is to go to atomic metabolism, go to something very small that has very few gears, and then you'll be able to maybe measure some of these effects. Now, that's basically GPS, in the sense that they're using a type of radioactive decay to measure time, because decay has a very standard, reliable, dependable, calculatable rate that a group of atoms will decay at. So depending on how much I've concentrated decaying atoms, I can know exactly how many atoms will decay for a period of time. That will indicate time. But this atom is just as vulnerable as everything else to the process. So to illustrate the problem, the metabolism of the atom is, I've used this analogy of dancing. If something's dancing as fast as it can, that's what it does. It dances. Then I ask it to do something else. I say, dance to the left or dance to the right. It won't be able to dance as fast. It has to take time out from doing its dance steps to do some step that causes motion in a direction, and that will interrupt the process. So it's basically as simple as understanding if radioactive decay is this clock, it's just a clock. The atom is running a 10,000 year alarm clock, and there's a process. Probably something like, I'd speculate that the process is something like, there's a little bit of decay in where this electron, how much force is interacting with it, or it's vibrating, and over time its vibration will just start to get more and more eccentric. So you can just sort of understand how that could happen. It just starts to get a little bit off because it's in an environment with other elements, and those other elements are going to disturb its rate of vibration, and eventually it's going to vibrate so much that the electron will fly out of the atom or something. So it's just some sort of process, okay, a mechanical process. And so you could understand it as just being, these reflections are a little annoying. So you could just understand that as a circle. Now that's the metabolism of the atom. Okay, that's its atomic metabolism. It's a process, and over that period of time, certain things will happen at a certain rate. Now, if I move that atom, cause it to move, well, that's sort of like just causing it to process. And as you can sort of see, the procession rate, that is how many times it can go around, will now be longer. These circles will now be caused to be bigger, a little bit bigger, okay, because of that change. So now I've changed the rate at which process takes place, because I've essentially forced these circles to be bigger. By making them extend in a distance isn't any different than me extending them in circumference. So the faster I make them go, the bigger the circle is essentially getting. So you can understand that there's a simple mechanism, all right, that you could understand atoms would have, that would change the decay rate of the atom by extending the process, by saying, 1 million of these rotations happened every 10 minutes before, and now that I've given it velocity, only 850,000 of these events take place in 10 minutes because of the larger circumference and the fact that everything has to move at the standard speed. So you can't change its speed, you can't change it. So it's dancing, and basically you're saying it just can't do it, if I'm forcing it to do something else. If I'm asking it to do another task, that other task will absorb time, and there won't be enough time to do what it was doing before. It has to do what it was doing before slower. So the same is true for a computer or anything else. If I make the computer do other things, its capacity to do the thing it's doing as fast, the fastest speed it could do it at, is now reduced, because it's going to have to allocate resources to the other events. And velocity or acceleration is an event. Now this is just a simple mechanical explanation for why there is a need to adjust clocks in GPS. Now, the irony has always been that most people think, I think that you could prove that statistically, with survey, most people think the satellites are the thing that have the broken clocks, that have to be adjusted because of too much dilation, because of too much velocity, because they're going fast. They're going 20,000 miles an hour. They're going very fast. But the truth is that what's really going too fast is us here on Earth. We're going faster than the satellite is going. We're more time dilated. They have to adjust this satellite to go faster, not slower, because it's going too slow. No, too fast, and we have to adjust it the opposite way. Yeah, but we're the ones with this clock is going too fast. Our clock is going slower. And our clock is going slower because we are actually dancing faster than the satellite. So even though the satellite's going 20,000 miles an hour, and we're only going maybe whatever 50 miles an hour, much slower. We're dancing essentially already in a force. That is, we're in gravity. And so this is where I think part of the Einstein notion of this of accelerations always being equal is, yes, they are, but more important, velocity is what acceleration turns into. And what Einstein didn't explicitly, I don't think, say. His first paper was about acceleration, so sort of about gravity. And then the second paper was extended that more generally to velocity. But the two really, it's always one subject. It's your net velocity is the only thing that really matters. Okay. And your net velocity is made out of whatever accelerations you're in the process of acquiring. Acceleration is a velocity. It's the process of gaining velocity. So anyway, the real point I wanted to make here, which just in this comparison, what's not appreciated is there's a difference, is written down there, real speed versus apparent versus net. Well, net would be the same as real, but anyway, we have an apparent speed, but that apparent speed is just what we can see, grossly. But there can be always hidden speeds in anything's motion. So you could watch a bird fly, and you could say it's going 10 miles an hour because you took out all the parts where the bird did this and did this and did this and did this, and there was a little bit of shudder in the bird's flight. So the actual speed, the bird actually traveled this distance in that time. And so the bird has this velocity, which is probably going to be 12 miles per hour. Actually, the bird itself is traveling 12 miles an hour because it's doing all of this stuff. Now, for the sake of our perception, we can get that wrong, and it doesn't matter. But this is physics, and it's got to be, you got to understand what's really happening to things. So the truth is, this satellite is in gravity. It's in an acceleration, but it's in much weaker gravity than we are. So as it's moving around, it actually does go in this direction, and and then it goes straight, and then it goes down, and then it goes straight, and then it goes down. And as it's doing all of this, it's not traveling a straight line. So the acceleration down is making a mess of its true path, true space. So the atoms that make up the satellite itself won't be doing this, but the atoms themselves, each individual atom will be, because each individual atom will spend some time going this way and some time going this way. So its life is really many directions, and so it's vibrating in the gravity as it goes around, in the sense that it's going one way, and then it's going another way, and then it's going one way, and then it's going another way, and then it's going one way, and then so it's a bent, at least, line. We're in much stronger gravity, so even though we're going much slower this way, we're going a lot deeper this way, a lot faster, a lot more acceleration down. So we're vibrating with a very high frequency. And so you can sort of see that even if this rate seems really slow, like the distance, the fact is we're traveling a lot of distance up and down. And that distance is the distance of our real velocity. That's what our atoms are really doing. So the body itself might be doing this thing that seems like only 50 miles an hour, as measured by the whole body. But the individual birds, right? So it's like you could think of it as a flock of birds or a school of fish. The school of fish could be moving 3 miles an hour, but none of the fish are going 3 miles an hour, because all of the fish are doing a lot of extra distance. And the same with like birds. The flock of birds could be going 4 miles an hour, but the individual birds are going much faster than that, because they're not taking a straight path. So the point is we're in the heavy gravity, so we're vibrating very, very big signal. The satellite's got a very weak amount of vibration, so the distance is more this way than this way. where our vibration is more this way than this way. And so we end up traveling more distance, our atoms, and therefore our atoms are more distracted. They're multitasking. They're spending a lot more of their energy, so to speak. The atomic metabolism is busier doing this, okay, than it is our bodily functions of atoms doing their little bits of process. So they're dancing slower. Our atoms are dancing slower than the satellite's atoms, because ours are more distracted by this obligation to travel all of this distance, to do all of this going somewhere. It's always going somewhere, so it can't read the book because it's always distracted. So it doesn't get through as many pages. So we're the ones cold, time-wise, even though we're actually doing more energy action. And that's one of the details that most people don't know, don't appreciate, and that can create this confusion that you need a dimension to understand. And you don't. You just need to understand that acceleration is a form of velocity, just as real as the satellite's motion in a direction, but that no velocity, you can't judge velocity based on saying what is the school of fish doing, because the real velocity is what are the fish doing, how fast are the fish moving, not how fast is the school of fish moving. And that's where people's logic and reasoning has been broken, is a lack of appreciation. See these subtle details, just like with the photon, as I was explaining. The deep truth is that the electron isn't reacting to, like say a photon comes into an electron, it's not reacting to each bit individually. It's reacting to the frequency of these bits and how that affects the electron's relationship to other electrons in pressure. And that's what's really, it's how long does this pressure take to get to here and then push back? How long does the pushback take? And these photons are capitalizing on the quickness of this spring between the electrons, rather than just having an I hit you relationship. It's more complicated than I hit you. If I'm hitting you at certain rates, I'll capitalize on this spring and I'll have all constructive pressure created. Where if I allow this spring, if the first photon hits, compresses this spring, well, if I allow this spring to push back, okay, before this next bit gets here, well then this energy of this photon is going to be opposing this energy, and you're going to get your destructive interference. But if I let this photon hit just as this maximizes its energy, its push, and there's no rebound yet, and then this photon comes in, now I can really compress this spring. And it's all constructive, not interference. There's nothing interfering. It's just constructive storage of energy. So our verbiage probably should change. Instead of calling this interference, it should be called storage, because that's what it is. So you can have constructive storage or destructive storage, where the storage is destroyed because of the fact that the energies are canceling. The directions are canceling. So much of the language is very broken in terms of making these arguments and understanding perspective, what's actually happening to the atoms and the mechanism. So so I guess we'll just go through some of the key words. I don't know if I need to say any more. So just understand that path of the actual objects inside of something is the part that decides what's the metabolism of the system. It really depends on what the little bits are doing, not the giant collection of bits, because they're doing all kinds of different things that are destructively interfering, in a sense, they're going as much this way as they are this way. So again, this is, there's other subjects that can be based on this understanding, and then, I'm just adding more axioms, which is something I don't want to do for these subjects. But, to understand how electrons function, I've sort of pointed out that electrons could have built into them a bias, in the sense that their engine mechanism is based on an odd number system. So they are either, there's 3 going this way and 2 going this way, and they have a bias. And the only way I can change that is to make it, 2 this way and 3 this way. And then it still has a bias. So it's always going in a biased direction. So it's always essentially vibrating, which is a kind of velocity, going back and forth and back and forth and back and forth. And that's real distance. And you do it based on over time, and it consumes time to do that. So they always have a velocity. They're never they're never at zero velocity, because they're always going. They're in some direction because of this built-in bias. All right. And so, when atoms are held together, so this is an atom, and I'll just redraw it because why not? We can, so we will. So if you have 2 atoms and you got this idea of an electron that they're going to both bond to, that electron, they think, is doing all of this motion, but what it could be doing in that little location is just going back and forth and this way and in and out. And so it's just vibrating in that location, and we're reading the vibration as a velocity. Okay, but it's not a velocity. It's not a real velocity in the sense it won't be going somewhere, but it's real in the sense of the electron is active. So we're measuring the energy, and what we're really measuring isn't some path energy, okay, doing all this slop. We're just measuring the fact that it's moving constantly, and we're measuring that movement. The energy of that movement. All right, so that's might be enough, maybe, possibly. All right, so let's just go over some of these keywords real quick. So I would argue that time dilation has nothing to do with a dimension. It's not a bendable thing. You can't change, you can't bend it, you can't twist it, you can't shorten it, you can't do any of that stuff. The light is a reliable function, and unless you change the speed of all the photons in the universe, all the little bits of energy, you have no hope of changing any dimensional time. You just can't do it. You're not going to warp a dimension and end up at some location in time. There's no time locations. There's space, and space changes, and you just can't erase the facts. So there's no way you can do something to arrive at some location at some other time, except change when you get to the future, so to speak. You could walk slower when you're walking to the store, but you cannot move the store closer. You can't change anything else. You can't go any faster than the set speed as a maximum speed, and those are all the limitations, so you're stuck here. And so there's just moments of time, and they just click off as photons move, and that's it. Alright, so real speed versus apparent versus net. So you do have a real velocity every moment in time. The trick is that there's a ton of force acting on you, so your vector, your real vector of velocity, essentially changes. If I could break time into a very small length, at that moment you're moving in a direction. In the very next moment, though, some force is going to act on you, some photon, and it's going to change the net disposition of the rowers in your boats, and the school will move in a new direction, but much of the motion ends up just being balanced. There's as much energy hitting you from one side as the other over time, over periods of long periods of time. There's lots of little periods of time, like I can flip coins, and there's lots of little periods where I'm going heads, 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 and I could say, oh, it's all heads. Coins don't have any tails. But obviously if I flip long enough, I'm going to go tails, tails, tails also. So there's lots of variation in movement, but there is no, it's not a dimensional thing. It's all just traceable to distance covered by a force bit. Alright, atomic metabolism, I've sort of gotten to that. Some people have a problem using the word metabolism, because that's a word we use for living things function. But we need a better word. We need a word like that for the metabolism of mechanical devices, because they have one too. They have reliable functions. They have clocks built. You know, if a refrigerator has a little clock built into it that tells it when to defrost and all that kind of crap. All these things do have metabolisms. All mechanical things, and atoms likewise have a metabolism. They're functioning in a state, and you can change that state, and when you change that state, you change the function. So if you heat it up or you move it, you're going to change how it functions. You're going to change its metabolism. Bounce speed, this is the important one, just understanding all my analogies usually have to do with like a basketball player. He's going at a certain speed, a velocity across the court, but the ball is going at a much higher velocity. We don't appreciate it, but it's much higher because it's traveling so much more distance than the player is. And that's your real circumstance. As you're sitting there, probably, you're pushing into the earth is pushing back, you are vibrating, your bits are constantly changing their motion to deal with the imbalance in the pressure that's constantly affecting you, because gravity keeps trying to drive you to the center of the earth, and the earth keeps saying you can't go in, and it's like a door being pushed back and forth. Gravity's pushing you through the door, you go through the door a little bit, then the people on the other side of the door say you can't come in, and they push back, and that's your real velocity, the real velocity of the bits that are you, and that's you. You're made of the little bits. The little bits aren't made of you. So their velocity is the velocity that counts. They're the thing with the metabolism. Alright, decay is just a process. That it shouldn't even be arguable. It doesn't happen magically. An atom doesn't spontaneously fall apart, deconstruct. Like your car or anything else, it has to bounce over the road a while before the fenders fly off and the hood flies off and the windshield cracks and all that stuff. It has to be impacted. It has to go through a process of deconstruction, and it takes time. And that's just a fact of some atomic structures. You can pressurize them, but they're leaking a little bit. That's the radiation. That's why radioactive isotopes are radioactive in a way. They're leaking, and that they're leaking a little tiny bit of force over time, and that little bit of leakage eventually will collapse enough that the whole structure of the atom can't stay together anymore. There's not enough attractive forces, there's not enough external pressure, internal pressure, and it breaks down and falls apart, and then releases a big burst of energy when it's falling apart. When the fuse burns out and it blows up, a better analogy probably. A pressurized tank, you put so much heat in and there's a certain amount of pressure, and once you've gone there, it blows up. Just kind of like that in reverse. Alright, clocks break. So the really important one is to point out is the exception. The except, that's right, except. The light clock. Photons don't break, and that's sort of what Einstein was. He grasped at that concept in the sense that he attempted phrasing it in such a way as people would understand that light is the reliable mechanism here. Light always travels the speed of light. But in this framed geometry that he created, he gave everybody every reason to believe it doesn't travel the speed of light, because somehow you could have a frame inside of a frame, and somehow those two velocities could end up creating a velocity faster than the speed of light. And clearly the implications of played with, they can make it do things that kind of point out how he didn't phrase it accurately enough to restrict those things. Seems apparent that Einstein did understand that a light clock would appear to go down the side of a ship if it was moving. If you're moving in a spaceship half the speed of light, the sides of the ship would make it appear that your light clock would fall much lower than perpendicular. It would look like it was traveling a bent line. When no, photons traveled perfectly straight. Now, there's people who argue that the implications of Einstein's theory is that light moves forward. Now, I don't think Einstein said that, but Einstein did say things like there's no experiment you can do to detect velocity, but the light clock would be an experiment you can do to detect velocity. So it's making these declarations, trying to establish some law, and it's just not a law, okay? It's a general rule that most clocks will break. It's just a fact that the one clock that won't really is the light clock. It's not going to break. You can't break photons. You can't break the force. You can only break the gears, okay, connected to the force of different mechanical objects that you're using to measure time. So you can break the gears inside of human functional clocks, but you can't break time. That clock doesn't break. All right. Yeah, you could go on and on about it. It's just such an important idea to understand that photons don't care about the speed of the emitter. They don't care the direction of the emitter. It's just totally irrelevant to a photon. Once it's in free space, it's doing one thing, traveling in a straight line at the speed of light. And all these people who still think of this whole ether crap and this waves of light, they don't understand that light arrives at a location and that we can tell that it's going to head right for that location because we just move the target closer and closer. It's moving in a straight line. There's no wave going anywhere. There's no photon over here and here and here and here. Photons are corpuscles of energy. They don't land as a wave. So how can you call them a wave? How do you explain how your ether vibrates in all directions and it only lands in one location? How do you explain that? Anyway, it just makes no sense. But I won't harp on it, but I might harp on it. So again, there is an experiment. The experiment that can always tell you where you're going at any one moment would be the light clock experiment. Light will tell you. The only problem is light is emitted by electrons that are vibrating. So we don't have a really good light clock. All our sources of light are doing this. They're not creating a consistent ray of light, a one thickness of photons traveling a straight line, one right after the other. We can't make one of those. We can just make guns that shoot all over the place. So our light clock is too broken because we can't make a good enough one. But in theory, it's there to be done. And obviously these time dilation effects only happen over large changes in velocity. Alright, real velocity, multitasking, dancing. So that's just kind of I think you can understand that that's what breaks the atoms, is multitasking. Because what they're doing, they don't just sit around. The electron doesn't just sit around, it's always moving. Now if I force it to move in a direction, right? So this is sort of like the drift speed in wires. Because physics has this problem where if they attempt to measure the speed of electrons when there's no electricity, they're moving faster than they're moving when there's electricity traveling through the wire. which doesn't make any sense, but it makes perfect sense if you understand, well, if they're not jittering as much, if there's less noise, if they're actually getting accelerated in a direction, if they're getting pushed somewhere, then they're not doing this anymore. And they might be doing a lot less of this. And so, because they're doing less wrong, they're doing less of their normal motions, which is this. They're doing this. That's their dancing as fast as they can. Now if you push them in a direction, they're dancing less and they're going in a direction more. So you'll see less motion out of them. And if I force them to move to the left really, really fast, if I tell somebody, move 20 miles an hour to your left, it's not even going to look like he's dancing anymore, right? It's just going to look like he's running as fast as he can to the left. The analogy really does work. I mean, it's really how it is. That's how the world functions. So he's using all his energy right now dancing where he is. And so any obligation to move in a direction has to slow down how fast he dances. And the more you slow down how much he dances, the less it's looking like he's dancing. I mean, you win. This is a bad dancer. Anyway, and that's the same is true for these physical objects. The faster I move them in a direction, the less they can do all this other stuff. So you essentially get stone cold frozen the faster you go towards the speed of light. All velocity can do to you is essentially cryogenic you. It's freezing you. It's stopping all of the molecular and atomic motion. All right. So acceleration velocity changes the thing moving. So just a simple argument. Big giant flame out of one end of the space shuttle. The same amount of force is going inside of the little astronauts and inside the aluminum and inside of the whole. All of those atoms are getting a bias just as substantial as that flame. Their percentage of it, their atomic mass percentage of that flame is going inside of them and changing their physical structure. You hold force like a battery holds potential. That's what you do. You collect it. Maybe not in the same sense. In the sense you exchange. You exchange stuff inside of you going this way for stuff going that way. You change the bias of those electrons. All right. Back and forth is a velocity. So accelerating, deaccelerating, accelerating, deaccelerating is the same thing as moving. It has the same time dilating effect. Faster it moves, less noise in the motion. So it just already kind of went over that, and the dimension argument. There's just no evidence that there's anything called a fourth dimension. The three dimensions are clearly physical places, and they used up all of the circle, so to speak. So you can sort of understand that the circle has a diameter this way, and the circle has a diameter this way, and the sphere, has a diameter this way. There's no more room for any more dimensions. So you can kind of understand the geometry doesn't encourage us to go looking for another dimension. They're physical dimensions based on solid geometry, cubes and circles and all the geometry we know of. There's just no indication there's any room for any fourth dimension that is in any way just like the other three dimensions. It has to be completely different than the other three dimensions, and so what's the point of it? You're just making it up, and you're using the same word as if that's appropriate. It's like calling an eye a foot. There's just no, it just doesn't make any sense. It can't be thought of. There's no more room for any more feet. And they can't be feet if they're hands. There's no reason to even think it's possible you can make another dimension that would be in any way suitable to use that word, to call it a dimension, that you could bend or warp or do the same things you're going to do to the other three physical dimensions. So the whole thing is just such a silly story in a way, and I'm just saying there is a rational explanation for the correlations. The fact that there's an association between velocity and what appears to be a retardation or a freezing, a cryogenic freezing of function, a breaking of the clocks, does not make Einstein right. It just doesn't, because it's happening for a reason completely different than what he's proposing. A physical reason that has nothing to do with time and space being things. Time is not a thing, it's a function. Space is absolute nothing. And he's using the word space to talk about a force called gravity, and he's using the word time to talk about something that really just has to do with the gear work. How disconnected is whatever you're watching from the speed of light that really caused it. So if you're watching something happen, like the pixels change on my screen, on the screen, those things are all happening because of the speed of force. They're not happening because these gears cause something. It's the speed of force that caused the gears to move. And you have to understand that that force can be going two ways at the same time, which means you won't see anything turn, because the gears turn much faster than you can see. So they look like they're in the same place, just because you can't see the motion. But they're not. They're moving all the time. Alright, that should be enough of a video. So, I'll be back. Any suggested proofs that there can't be a physical relationship between gravity and a physical process, and time and a physical process? Yeah. And that those processes require you to stay within the boundaries of real physics, which is you can't make light go faster or slower ever, or any other force. You can't change the speed of force, therefore you can't change time. Alright, so till the next time.